All right, so as we're moving through solving these polynomials that you can't factor, we're going to have to use rational root theorem to generate a list. We use Descartes' rule to kind of narrow down the possible number of roots that we have. And then from here, we're going to do a thing called the remainder theorem. And the remainder theorem basically uses the notion that we know that if you plug in, you do an input value. So if we do f of 2, and we plug it into the equation, we get a y value out. So the fact that we know that from Algebra 1, when we have an input, our output's going to be a y because our x is our inputs. So with that, we're going to look for x-intercepts. Well, you ask yourself, well, what's the y value at an x-intercept? Well, that's a 0. Well, what that really tells us is that's where it's going to cross the x-axis. Also, as we progress to reduce these polynomials so we can get to something more manageable, we're going to be looking for things that have a remainder of 0, which is actually at the x-intercept. So really what we're looking for is what x value are we going to put in to get a y value of 0, because then we know that's going to be an x-intercept. So here are all of our possible x values for x to the fourth minus 4x cubed plus 8x squared minus 16x plus 16. These are all of my possible rational zeros for that polynomial. Now, I went ahead and did Descartes' rule assign, and we can see that we can have 4, 2, or 0 positive roots, and we can have 0 negative roots. So at this point, what I'm going to do is I'm basically going to pick a number, and I'm going to start evaluating it until I find it where it equals 0. I'm not going to pick any negative numbers because Descartes' rule assign just simply said, hey, you know what? There is no negative, so don't bother. And they're up to 4, but there could be 0, but for this class, it's either going to be 4 or 2 positive roots. So I know that at least one of those could work, 2 of those could work, 3 of those could work, 4 of those can work for this class. So what I'm going to do is I'm going to pick the easiest one to do math with, 1. And I'm going to do f of 1. I'm just going to plug it in. So 1 to the fourth is 1 minus 1 cubed is 1 times negative 4 is negative 4. Then we have our plus 8 minus 16 and plus 16. Let's see, so those cancel out. This gives me, let's see, negative 3 plus 8 gives me 5. So nope, that's not an x-intercept. That's not going to be a root because when I do long division or synthetic division, my remainder would be 5. So let's try the next easiest number to do math, which is 2. So f of 2 is going to be 2 to the fourth minus 4 times 2 cubed plus 8 times 2 squared minus 16 times 2 plus 16. Okay. So let's see. This is 16. 8, this is 32. That's 4, that's 32. So that looks good because those cancel. This is 32 plus 16. So those go away. 16 and 16 makes 32. Minus 32 is 0. Boom. So I now know that 2 is a 0 for this equation. And you can keep doing this and find all the other ones. But from there, this is where I would launch off into our next step of solving this, which we will do in the next video. But we know that 2 is going to be a 0, so I'm going to actually end up using that for synthetic division to reduce this polynomial. So that's the whole idea of the remainder theorem, is basically just take one of these numbers, use this to kind of guide you on what you're going to pick, because if I started with a negative number, that would just be crazy because none of them work. But I knew the positive would work. Use that to help guide you. Plug it in. You do some Algebra 1, which is arithmetic. Just evaluate the function. And what we're looking for is 0. And that's going to tell us that our remainder is 0 of this polynomial when we do synthetic division with 2 or polynomial long division with x minus 2. Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.